See where we at. Alright, Restream is on. Is Twitch on? Find out in a minute. Alright, Twitch is... Oop. How's that? Is that good? Is that about in the middle? Maybe I bring the table down a bit. Yeah, okay. Twitch isn't streaming yet. Alright, Restream is streaming. Twitch is not. It's set. Restream says I'm supposedly streaming on Twitch. Twitch thinks I'm offline. Maybe I need to refresh. Alright, live on Twitch. What about YouTube? Live on YouTube. Alright. Let's go. Welcome to Go to Hangouts number 199. The last one before I need to figure something out special out for everybody. Today I'm gonna look at doing basically what I was working on last stream, but to do it as a shader in WebGL. So I haven't touched WebGL in quite a few years, and I'm looking at some old code in CodePen that I did back in the day, and I created some little wrappers for like textures and shaders and stuff to make things a little easier. But other than that, I'm not using 3JS or I'm not using anything. So here, for example, I had like I was working on a layout for shelves in my washroom. That's my washroom. A diagram of my washroom. And because I don't know how to use CAD, I created a shader that did it. I have this one, and I have this implementation of Conway's Game of Life in a shader. So I'm basically looking at these as a reference. And here I've kind of copied a lot of the boilerplate over, but I haven't actually drawn anything on screen yet, right? And the idea for the shader, probably this is going to be the closest thing, where I'm basically, so in this Game of Life, I'm passing in the texture, the pixels here as a texture, and then I run a shader over it. And I don't, so I have the shaders here in the HTML as sort of thing, right? So GRL stands for Game of Life. So we have Game of Life draw vertex fragment, we have init vertex fragment, and we have just vertex fragment. So probably not all of these are being used. So I'm kind of going through this code. It was a long time ago, so I don't remember exactly what was going on here. We have init shaders. And what init shaders? I think all of this is the init shaders. Yeah. So if we're looking at this, it's basically creating a shader object, which is a little class that I've built that I've copied over here as well. For each of those. So we have the text quad, fill quad, fragment, init. Now, hopefully what we want to do will be easier because we don't actually want to render it out, right? And I think the Game of Life thing, I don't remember if, I'll be honest, I don't remember if the actual update is happening in CPU land or in shader land. And I'm starting to think it's happening in shader land. So if we're looking at the shaders, so init, I guess, just sets it up. We have a random number generator. All right, let's see when these are being executed, right? So we're creating the textures here. They're getting assigned to these variables. Excuse me. And I'm guessing one gets passed into the next. So, okay, since I can draw onto this, right? Let's look at the mouse stuff. So here is where we're drawing into the textures. So draw into Game of Life data, this says. So init Game of Life data does what? So it sets seed values. So, okay, I have support for seed values. Shader, Game of Life init. Okay, so these are all the shaders that I'm setting up on the context. I'm wondering if they're referencing each other in any way. Game of Life buffer objects. Objects width. Oh, yeah, okay. I used to know so many things. So when we're drawing into, we're having a target frame buffer. So we're trying to draw into FB1 and FB0. So I'm guessing we had basically 2 frame buffers that we're swapping here. 0 and 1, right? So we're drawing from 1 to 0. So source, okay, so frame buffer 1 is the source, and frame buffer 0 is the target. So I'm guessing, so we're binding the frame buffer. So I'm guessing bind frame buffer is something we're doing here. Get frame buffer. Get frame buffer. This frame buffer is undefined. Create frame buffer. Bind frame buffer. GL bind frame buffer. So we can assign them as a frame buffer. But what does that mean? I guess we might want to look at that. WebGL bind frame buffer. Binds to the current, or if the frame buffer argument is null. So I'm guessing that texture is what the canvas renders into. All right. Yeah, exactly. Okay. So then what happens? Drawn to GOL data. So shader, GOL draw. So we have a draw shader. So I think the draw shader, all it really does is it gets us like whatever clicking causes, like a white dot or a white circle or whatever, right? UV position divided by 2.05. Even when getting my head around fragment and vertex shaders again, oh, it's gonna be a pain in the butt. Mix. So we're mixing color. Okay, but thankfully we don't really need to care about most of that. What we do need to care is how to get the data into the shader and out of the shader. And I don't know if I'm actually getting data out of the shader, because I think I build it in such a way. Hey, Vanessa, how are you doing? Let me know if you know anything about WebGL, because my knowledge is rather limited. So I think what I did, I think I'm running Conway's Game of Life rules in shaders. And I'm trying to verify this by looking through here, but I don't see the Game of Life rules being implemented, actually. Nope, here they are. Okay, so this is the fragment shader that actually implements Conway's Game of Life rules, right? Now, what I don't know is if the rules are encoded here. So, in other words, if I've just hard-coded, yeah. So I've just hard-coded. I'm basically looking at the 8 surrounding cells and the cell itself. 1, 2, 3, 1, 2, 3, 1, 2. No, I'm looking at the 8 surrounding cells, right? So we're doing texture 2D lookups into UD texture. We start out with the color. We have a reference to the color itself as well. Don't know what the R stands for here. .R. Oh, RGB. Okay, we're drawing into the red channel, right? And R versus C.R. What is... So R... So here we assign the original red value from the color to R. But here we're changing it according to these. And then here we're writing RGB in. Ah, yes. Okay, so I think the red channel is the old color. The green channel is something. So the green channel we're not touching. So the red channel is the new color, the red-green. The green channel is the old color, and the blue is the... Okay, so we basically have 3 frames of history here. So the red channel is the current color, the green channel is the previous color, and the blue channel is the previous color. So let's change this here, just as a little sample. So if I do this, we should get rid of the color, the chromatic aberrations of our little thing here. Fragment shader is not compiled. How do I make a comment in a fragment shader? Comment in WebGL fragment shader. I don't know if we can comment. GLSL. Syntax. // I think the hash is for E. Here we go. Okay. All right. So if we assign a color, maybe we can write something. So we have a vertex shader here. The vertex shader doesn't need to do much. So let's see if we can. Maybe I can just copy this over. I don't know if this makes sense, right? Oops. Also, I don't know what this version should be. WebGL version 100. What does that mean? It gets WebGL 1. If you ask for WebGL 2, you get WebGL if the device supports it. If it does not, it's not compatible. Top shaders, nothing. One shader will fail to compile, and a lot of features will be locked behind extensions. I'm going to leave it out since I don't know what it means, and I'm actually asking for WebGL 2 context. So if I do this vcolor, if instead of doing vcolor, I just say vec for 1, 0, 0, and I think that needs to be 1.0 because of reasons, and 1.0. Right. Now, this may or may not be valid. And why is the version over here? I guess maybe I copied that from a different vertex shader 1. Vertex shader 1 fragment. Okay. I think the naming is actually something I've established in my little shader class. So we'll probably want to stick with that. So now we need to get it to execute. So let's see if we can figure that out. So here we now need to look at the init shader stuff. Init shaders context. Now init shaders creates all these. So we're pulling the source out, and then we're creating all of this. Okay, so let's see. What's the simplest one of these? So if I remember, this is some variables for passing data in and out. In the moment, I just want something, anything to render on screen. So maybe if we look at this one instead, init shaders, init shaders. Where does it say? Okay, we have main. GL shader. Because I think it's just pushing these into arrays and such things like that. Where do we actually creating the shader? Shader update. No, shader. Shader, here we go. Create wireframe. So it does create wireframe. Create a shader object. Yes, it does. Okay, so this would be some sort of shader object here. And the projection matrices, do we need them? I don't think so, right? Because we don't have any of that stuff here. All right, let's just grab one of these for a sec here. And we are doing init shader happens where? Init shaders. Okay. Let's do this. Shaders. All right. And we'll do async function init shaders context. And the context is just my little global thing that I'm using to push things around like references and stuff. So let's do shader 1 vertex and shader 1 fragment. Shader 1 vert and shader 1 frag source. Right. So that should just output the shader down here. Yep. Okay. All right. Let me keep a glimpse on the console. I'm just realizing my right edge screen edge is going to be cut off, and I apologize for that because normally I work in a text editor. Let's move all of this over a bit to give ourselves a little bit of breathing space. Is that better? No, not yet. All right, I don't think we need the line numbers. Sorry about that. I'm just testing you, see if you're paying attention. All right, so we need this, we need that, we need GL from context. Right, we do need the matrix stuff, which I haven't copied over. So let's get all this matrix stuff, matrix helpers. That, don't need to have them open. Should probably make that into some sort of class or something. Okay. Quad vertices. Probably don't need that. A vertex position. Is that a thing we need? Uniform model view. Let's just find another shader here and see if any of these shaders don't need this. So they all seem to have model view. They don't all have hue fill color, so we might not need that. And attributes probably don't need it. So if I remove that, okay. Now, shader fill. So let's call the shader 1. When are we using this variable name? Okay. Shader text dot uniform texture unbind frame buffer. So we want to use this as a frame buffer. And the FB1 is where? FB0, FB1, GL buffer options. Let's get texture. Oh, wait, they're not shaders, they're textures. Ah, okay. So we need a texture. Before init shaders. So if I do something like this, maybe something like that. And we'll probably want to init that somewhere else. Let's init it inside init shaders. I think it makes sense. So if we create something like a frame buffer 0, right? And I don't know, 100 by 100, right? That's all the filtering. I think this was set up so I could have these sharp pixels and no blurriness, but that's neither here nor there. Now, the frame buffer. How do we write into the frame buffer? Shader goal init, shader bind, unbind frame buffer, draw quad. So somewhere we're binding for init, and then we're unbinding. And the init GOL data, init game of life data, we're passing in a frame buffer. So where exactly is that happening? Let's see. So we're initializing game of life data. The probability is used where? Shader, probability shader dot bind. Shader dot bind does what? Shader bind. Shader bind this program. Okay, shader bind just says execute this shader. I don't know if I've ever run multiple shaders at the same time or how that even works, or I don't remember actually. I mean, obviously you run multiple shaders, but when you bind and unbind them and all that, I don't recall at this moment. Thankfully, we don't care about that. So we have our texture. So we have our frame buffer textures. We're initializing our shaders. I think the shaders don't care about the textures, or do they? They do, because that's how they get data. I don't know. Right, well, getting textures, shader game of 5 texture. So these have access to a texture. But if I do this, and this is all happening during the initialization, right? So init shaders context. So after init shaders, so at the end of init shaders, basically, we should be able to say frame buffer 0, bind frame buffer, right? And then the shader will do, if I just say, whoops, dot bind. Now here we're unbinding the frame buffer afterwards. Okay, because that's doing init. Then doing update, doing rendering. We're binding a shader. And then at the end, we're unbinding. So we're binding and unbinding each frame. I don't know if that is what we're supposed to be doing. And then draw quad, I'm guessing that just draws something. So if I do this, triangle strip, because I was wondering if the draw quad basically just renders the texture onto the screen, you know? Okay. Well. So, oh, and this happens after the unbind. Okay. The problem I have right now is I don't know if anything is actually executing. And I was actually looking through these because I remember doing like a very basic sort of just super raw WebGL, just drawing something. Yeah, for example, here, drawing a sprite sheet, right? I'm wondering if I've got something here that doesn't use my... No, it does. Even this one uses my shaders, but maybe it's a little simpler than the other ones. There's no animation, etc., right? So we're setting up a texture with a sprite sheet. We only have the one shader here. Out color. Okay, so wait a second. Is out color something I'm creating inside here? Let's see. Today is going to be a relatively short stream because the American Mathematical Society is having a talk at the moment, and it's in an hour and a half. The next one starts that I don't want to miss. And unfortunately, I can't live stream it, so otherwise I would have just watched it together with you guys. Let me just... So we have the shaders. Oh, here there were classes. Oh, okay, so this was like an... Either this is a more advanced version or a more primitive version. I don't know. We're also doing... We still have the draw quad here, which seems to be important. So what happens during rendering? I think that's the important part. So under render, we take the shader, we're binding it, we're doing a draw quad, we do a bunch of this. Let's see if we can do like a bunch of clear stuff and don't have to worry about actually rendering anything for now. So let's look at the handling of the rendering. Handle render. So if we go here, right? Alright, so that doesn't render anything. Okay. Maybe if I don't have the shaders initialized? Ooh. Something. Color buffer bit. Red, green, blue. it's something. Oh wait, it's 0.1. What if we make it 1.0? Does that give us a bright red? Ooh, okay. Alright. Alright, we are beginning. Alright. So. Alright, so go back to inner shaders. So at least now we have something which will let us ideally figure out if something is happening, right? Oh. This doesn't work anymore, or we're not operational yet. Huh. Is it because of the frame buffer binding? Alright, what if we do this? Okay. So if we say here, so after this, I'm kind of going by this order. I don't know if I need this. If I do shade, well, you know what? Let's keep it there for a sec. And remove it later. Right now, I just want anything to happen. We'll do this. And I'm guessing I might as well. The draw quad function. This seems to be just like, hey, Phil. So if I do this here. Right, and then we can just, after the binding. So interestingly, the moment I bind the shader, we lose our magenta color. Oop. What's not right? This is not right. Okay, and if I bind the shader, what happens? Okay. Now if I do draw a quad, does that do something? Context is not defined. Yeah, because it's bound to this here. Okay. The problem is I don't know yet if this is correct. Since this just draws onto the screen, maybe I need to clone this over. Ah, here we have the 300 version. Okay, let's see if that works. So medium float, at for U transform a position in. This is this, I think, even simpler than the other ones because it's just drawing a raw something, right? And here we're calling it GL frag color, while here we're calling it out color. Okay, let's put that there. Medium float, same as that. Varying the color. Void main. And I don't know where that comes from. Okay, but now what if I change out color to be this? And I skip the texture lookup. I still don't, unfortunately, I still don't know if this code is even executing. And unfortunately, I also don't know how I can kind of log from there. Oh, save it. All right, so this is definitely not a red color. So our shader is, I don't know if it's not executing or if it's executing and... So shader bind draw quad. Super size sprite sheet. So if I do this. Okay, so this does the trick. So if I do this, before shader bind, and I do that, and I'll say const shader equals shader 1, and I kind of keep the syntax like this. Then we have the drop, this, and then at the end we have the blend disable. which again, I'm not entirely certain. But as far as I can tell, this kind of mirrors that. Mat 4 is not defined because this is different now. Is that more advanced or less advanced? Again, I don't know the timing of these. Does this have information about when it was created? Pen details. Anything about, I don't know. But here I had obviously some sort of matrix class that was hiding these things inside of it. Well, I guess I can just, for now, I can just use the function names. So just mat identity. All of these are expanded again. How many more times am I gonna have to collapse these? Oh, I hate that I can't collapse these indented groups, which I can in Sublime Text, which is so nice. Just indent a whole bunch of functions, collapse them as one thing. Don't have to enclose them in a class or anything like that. All right, accept timeout. Did it just uncollapse everything? God damn it. Just because I saved? Doesn't make any sense. Oh, is it just gonna uncollapse them again if I save again? That would be terrible. Init shaders, draw quad, init. All right. The matrix mat for identity should be able to just do this, right? Cannot read properties of undefined reading value. Shader U transform dot value. Init shaders. So probably I need to have. Why do I care about a transform actually? Am I using the transform here? U transform value. Yeah, I don't think I need that. Okay. It's still not actually rendering the shader, unfortunately. GL position, A position. Let's see if we need to bring those over as well. So the shader gets set up. We have a bunch of texture stuff here. Ah, here we go. So if I look at the shader over here, we're setting it up without attributes. Okay, so here uniforms, U texture, U transform, U model view. We probably don't need that. Okay, we have our shader sources. Let's just bring them in directly here for now. Make the whole thing a little bit more compact. Like that. And then we have attributes A position. U form, wait, what? Fail to execute uniform matrix 4FV on WebGL 2 to provided value cannot, oh my god. Maybe I shouldn't be on WebGL 2. Let's see, what can we learn? Problem accidentally created two x-axis functions in my program. The way I designed it, Same name, which gave me the error, and renamed one to axis rotated. My problem got solved. I don't think that's my problem. Provided on WebGL to run uniform matrix for FV. Uniform matrix for FV. Oh, wait. Maybe. Okay, because these are from different implementations, maybe there's something different here that's not compatible. Find V. Uniform location false uniform dot value or this array. Uniform.value equals uniform.value met for identity. Okay, it's pretty similar. We have an error here as well. Text permanent texture prompt. Okay. Let's see if no, this is also WebGL2 context. Okay. So far, these seem to be pretty similar. Failed to execute on the provided value cannot be converted to a sequence. Get uniform location program name. Program name. U texture uniform. U transform uniform. We don't need them, as far as I know. Did we just remove them? Maybe because of what we're using up here. So over here, we have a U transform uniform. Uniform U transform. So I feel like we need it. If I put it in, it breaks. Okay, maybe it's not initialized correctly. My god, I've forgotten everything about WebGL's programming. All right, let's see. We have the code, which is, I think, the same now. Right. We have these uniforms, and if I add them, we're getting a problem. How are we assigning the textures? So we have the sprite sheet. So that's happening here. uTexture.texture. Set params. Okay. But we've removed the texture. Let's look at the one that doesn't have a texture, which is the wireframe one. This guy. Well, actually, even the Game of Life doesn't have a texture. So let's have a look at some of these uniforms. It does have a texture. Yeah, of course it does have a texture. But it doesn't have a U-transform, so we might not need a U-transform at all. So if I do a texture, shader, Game of Life texture. So if I do a texture here, can I assign the frame buffer here? Let's not worry about that for a second. If I just want to draw this thing, there's also another one, which is the Sprite Galaxy. And I think the Sprite Galaxy, yeah, WebGL from scratch. Maybe that's actually going to be helpful because I'm guessing this doesn't use my frameworks. Yeah. All right, so in this one, I really started from scratch. So let's look at the shader. It's more complex because most of the code is in the shader here. I probably started simple and then just didn't stop. Alright, so this does animated tinted textures. It looks up the frames in the animations. The animation data is stored here. Alright, I guess I was getting a bit clever there. But here we're not using my texture and sprite and shader classes. So this is all from scratch, right? So we're just creating them, use program, yada, yada, yada. So kind of what I want to do is this. Well, the other thing I could do is I could start with this and then work my way backwards to here where I can just... Because I don't actually need to draw anything, right? I just need to be able to pass data in and get data back out, right? And I might not want the whole shader texture thing. Although, of course, being able to access the textures in a structured way will be very helpful down the line. All right, so sprite arrays, sure. Init shaders. So here we're setting a bunch of stuff up, which we don't really need. ultimately the shader outputs a thing, right? A pixel color. Do we do anything with positioning here? Because I'm also wondering if maybe how I set up this shader code here, it just doesn't, it tells it to draw something, but draw it 0 pixels across and 0 pixels tall, for example, right? So we have the vertex shader first, and then fragment shader below. The fragment shader is doing this. And then unpack RGBA, GL position, VUV. VUV, we need VUV here. What are our outs here? We have a bunch of varyings, but we don't really have any outs. In position, like, I don't actually position mean float, met4, U transform. Don't actually need any of that, right? Index vertex attribute pointer. Vec floor. So, whoops. If I go from 0, 0, 0, 0, position is XY. So that's a vec2. So this is the vec2. So then we're adding 0, 0, and 1, 0. Okay, so this should pose us as, let's just put it in the middle and see what happens, right? Tint color, don't even know where that comes in here. That goes into the fragment shader, okay. Then we have GL frag color, so I don't really need an out here or an in. And then I can do this. UV. That should just... Why does the fragment shader output a color? Gradient reading properties of undefined bind. Wait, what? Program link error. Fragment shader is not compiled. Uniform sampler. Yeah, we don't need that. Float. I don't know the GL frag color where that comes from. Is not compiled. Okay. Why not? Why do you not like to be compiled? Position, medium float. GL frag. Maybe 0 to 0. I hate that syntax for forcing floating point stuff. GL SL validator. Like, I have no idea how am I supposed to program a shader, like, to get actual... Oh, maybe shader toy. If I go here and look at, like, if I just want to create a new shader, which I, to be honest, don't actually know how to do that. Here we go. So, they're only giving us a fragment shader here? Void main image. Out frag color. Yeah, I'm not familiar. If you would read the rep carefully, then you would find the frag in chapter profile built-in language variables as blah blah blah. The following fragment output variables are compatible in the fragment shader when using the compatibility profile. Frag color, frag data, max buffers. Writing the specific fragment color that will be used by subsequent fixed for okay. The problem is, how do I get help on getting that compiled properly? Read the log by using GL20. Huh? Ow. GL20 is not defined, so GL20. I'm guessing this is not just in the browser somewhere. Ow. But that is not a varying variable. Or maybe is it this one up here that's causing the problem? No. Fragment shader. Clearly has a problem with the fragment shader. If I do this. Index out of range. I used to know all of this. This is not helping me. All right. Let's go back to something that works. The problem is it's also a different version and it's all sorts of different things. Uniform U transform in a position. Where is that causing an error? GL array buffer. Add attribute. So I am trying to add an attribute somewhere, apparently. Except I don't recall setting any attributes. Oh, except I am. All right, I don't actually need this right now. Okay, so we're back to here. Can I frag color instead of out color? No. GL frag color. Uniform sampler UV offset. You see, I don't understand which part here is required and which one isn't. Fragment shader is not compiled. But why? All right, WebGL get shader compile error. How do we get the shader compile error? GL get shader info log. So after the shader is being created, which is happening somewhere around here-ish, who knows? New shader. So we do this over here. What do we get? No, nothing. So we have to do a try catch on this. Is that gonna work better? No. Where's the error happening? Shader.create program. Oh, is that my own error handler, perhaps? Whoopsie daisies. Oh, that is the error. Fragment shader is not compiled. Fragment shader is not compiled. Wait a second, but then if I'm throwing an error here, Why can't I catch it here? Why can't I catch the error here? Is it because I'm not actually throwing an error here? So I'm creating the shader, then create program. This create program. It's not throwing a new error. It's just throwing. You have to do this. Before share shader. Program link error. Shader is not compiled. I still don't understand why I can't catch that error here. We have shader, use program, create program. So if I do a try catch in here, and then I'll do something like new shader. Like if I do this, for example, error in new shader. Okay. And then if I do throw error. So error new shader, throw error shader.create program, uncaught in promise. Wait, what? Uncaught in promise. Okay, error in init. But now the exception traveled out. Okay. I don't know why it wasn't traveling outwards before. Is it because it was in a constructor? Trying to recall if there used to be something weird about that. Error in it. No, it's working. Okay, so maybe just because I didn't annotate the error message, I didn't actually realize what was really going on. Get program info, get program parameters. If not, get program info log. Link error fragment shader is not compiled. Okay, that is not super helpful. Get shader info log. Get program info log. Can I get shader info log? Let's have a quick look at that. So if we do this, right? And then we do this. And this. And then we'll see. Let the information roll in, right? So, vertex shader compile. Okay, that's already a start. Now we know that our vertex shader is good. Fragment shader compile state is false. Okay, we knew this. Error. Oh, right. Now we're getting some information here. Shader info log, program info log was the wrong thing here. Okay. Dimension mismatch. Oh. Can us convert from const 4 component vector to float. To const high p float. Vector to float const high p float. So GL frag color. It's supposed to be a vec4. What? All right, let's see if we can get something here. Hey, we're making progress. All right, we've got to relearn a bunch of stuff. That's kind of why I want to do this now, because I know that I have to do some basics, relearn some basics before I can actually utilize the tools. Okay. Projection view model vec4. Lens you get the compiler here assigns a float to a vec4. A float to a vec4. Are you assigning a float to a vec4? Float. But I am not. Unless I've got a real wrong syntax. No, with vec4 GL frag color. A frag color type. Frag color. Call texture to D. vec4. Or float to const high p float. What is this? High precision float. USL values are not integral values. Oh, I think the shoot. Some of these values aren't right. Okay, so if I do something like this, that'll just work, right? Has to be. We can't have a type mismatch. Can't modify a const. GL frag color undeclared. Isn't that a freaking built-in? Come on. Oh, okay. So I cannot use GL frag color. I have to use the out stuff. So if I do out color equals like that. Okay. Okay. It does compile now, so we're ahead. We're slightly ahead compared to where we were before. Unfortunately, I'm mixing GL versions, so that's a little annoying. Do we have a similar issue with the vertex shader? Out, in, out, VUV. So if I do this, for example, out VUV, and then I'll just say VUV equals vec2 0.0, something like that. So VUV 0.5, 0.5. Maybe our quad drawing is problematic. There was something here about the size of it. I remember, like, there was a second block here. So, when we're setting it up, mirrored repeat. Hey, babe. Huh? Oh, the stairs. Oh no. Is everything already up? Oh, all right. Sorry. Okay. So, new transform. So, new transform. We're doing the transform here. Position back 4 times new transform times position. GL position here. Okay, GL position, but so GL position does exist. I don't know what's like a neutral. Just draw it there. Nope. Oh, that's not it. We're multiplying the transform. We're taking the position and then 1, 1. So if the position is 0.5, 0.5, for example, VUV, do we even care about that? Not really, because it just gets passed on. Okay. And a position is an in vector, which is supposed to come from the attributes, which I probably don't care about. Right. So we have the U transform here, which we don't care about. The problem is I still don't know how I get it to draw it across this area, right? What tells this shader where the extent are, the extent of what to draw is? Like, where do the vertices, well, the vertex shader come from? I guess from the quad. So I'm guessing here we have the same issue, right? So for example, so this is our game flash. I'll put the frag color. And there's probably a reason why this is not on version 3, because probably I had issues trying to figure that out. What's bothering me the most right now is that I can't get the vertex shader to just do something, right? Real position. Is the line drawing here, not this one, this one, is that version, it's also version 1 instead of version 3. This is version 3, but this one is also not drawing anything, because stats are not defined. That I can fix. That I can fix the way I fix it here, right? I think it just did this, right? So if I do that here, and then get rid of that bad reference, which isn't even here anymore. And now, that isn't the one that I needed fixing. This is the one I need fixing. Oh, I was still scroll wheeling. We should be able to remove that. Hey, here we go. Alright, so that's executing the shader now. And how does this handle resize? Okay, so let's have a quick look at the shaders here. They're version 3.00 here. So we have that. U transform, we don't care. GL position. So we do have a GL position here. What if I do that over here? We learn something from that? It's gonna... Okay, that's actually useful because it means having that over here doesn't actually work, right? I have no space. So, it's using U transform and A position. 1, 1, minus 1. This is a 2 by 3 matrix. What is this? That doesn't work. Is it a 4 by 2? 1, 1, minus 1, 1, 0. Count 4. A position. A position. Back 4, A position. I don't even know what it's pulling out of A position here. Okay. I do this. If I do this. I don't know what's in a position. I mean, a position here. Let's see. Is this getting changed anywhere? 1 0 1 0. As far as I can tell, it's not getting changed anywhere. So a position should really be these two values. And just to confirm, this is still working, right? I don't actually understand how vec4 takes something that's an array buffer and has 8 elements. Wouldn't it just take 2 of the elements? And why wouldn't that be equivalent here? Ah, wait, is a position, is there maybe another shader affecting that? Don't think so. Position. I mean, these are all input values here, so I can't even modify them if I wanted to, right? What if these are negative? Nope. What if they're one positive, one negative? I mean, I don't know how this determines which of these values to take. Oops, that is 2. I can count. Let me have a look at, I'm guessing, add attribute. Or bind attribute, array buffer, item size, vertex attribute buffer. Add attribute. So, creates a buffer. It uses item size and item count to generate an array. Attribute value, blah, blah, blah. Okay. What I don't understand is how it translates from the... Why I have 4 items here, basically. What if I change this to 1 item? Change this to the one that works. So maybe it has 4 different positions. I don't have... I have no memory of this. Is this the one we're actually executing here? SDF vertex source. This is SDF text vertex. SDF text vertex source. So that's this one, right? So if we clone this and then remove all of these, that doesn't work anymore. It's funny how the item count doesn't seem to make a difference. What's the other shader? SDF text vertex, SDF text fragment. That's all the glyph stuff. Text quad. Text quad. I cannot remember what this position error is supposed to do. Is this describing a cube? Or is it describing a 2x2 normalized matrix? Let's see how. We have 8 elements, right? So 1, 1, minus 1, 1. 1 minus 1 minus 1. Okay, no, these are the 4 points of a square. The top left, bottom left, top right, bottom right. Okay. All right. All right. All right. All right. Okay. Wait. All right. I think I'm finally getting it. I think those are the 4 points of the quad that I'm trying to draw, and that's what our fragment shader gets. And our fragment shader gets one of these at a time out of the 4. And that's why we need them. And that's how we tell our shader for which vertices to actually execute. So, put the attribute in here. Right. Make sure I put all of this back to how it was. And now, we'll basically need to do this anyways. We might be able to get away without the UVU thing. The transform, let's bring it in for now. Right. And we'll probably just add that here as a uniform. Like that. Okay. And it's lowercase m for identity, like that. Okay. Yes! Hallelujah! Hallelujah! Okay, alright, alright. If we do out like this, and whatever this is that the same as this? Like, if we do that, and then we'll have in VUV here, and then I can just say, I don't know, VUV is what? Vec2. So if I just say VUV here. Ah, look at that. Okay, all right. Okay, so we don't have the in and out yet. For that we need to figure out the whole texture thing that I've got going on here. The next step is, how do we multiply large matrices? So WebGL multiply large matrices. Because I don't want to actually have to implement matrix multiplication from scratch. So the question is, can I create my own larger matrices? No, if you want still think, so what? What's the point? It seems like a lot of work just to do the same thing that we're already doing. This is where the magic comes in. So you can multiply matrices together and apply all the transformations at once. Assume we have a function m3 multiply that takes two matrices, multiplies and returns the result. Okay. Okay, let's try to build matrices for translation. Okay, but this is in JavaScript. Oh, no. Well, word position, yada, yada, yada. Now let's change our shader. The old shader looked like this. Much simpler. Multiply the position by the matrix. Yeah, okay. Draw the scene. 3FE, multiplication of her matrix, yeah. But it's still doing the matrix multiplication on the CPU. I think I have to implement it myself, don't I? So we'll basically need to bring our matrix multiplication algorithm, which is this one. Okay, so we need to bring 81. No. These matrices are 81 by 9 already. So 729. Ones and zeros. So there probably will be a better way of doing that. WebGL multiply large matrices. How to make large matrix multiply. Load. Just pass a second matrix as a uniform array of floats. Perform the multiplication element by element. Not that it's too slow. You can try packing your large text in such a way that you can read 4 elements with a single textile fetch. So we'll need to store the second matrix in textures as well. Just not sure of the performance impact of doing so as opposed to sending it as a uniform. First profile, optimize later. Yeah, okay. So we do have to implement our own matrix multiplication. So, I'm guessing what I need to look into as a first test is to pass the data in as uniforms and see how I can get it back out. And the second test is to then convert that to texture input output like this. Because we don't want to pass in huge arrays. Because we do want to pass many things, but we don't want to pass those in by uniforms. And then we have to think about, okay, so we have a couple of steps, right? Because I've thought about also packing the matrices, but maybe storage space isn't our biggest issue. So let's do a little bit of math. So let's say we're actually storing each. So each matrix is 81 times 9. Whoop, 9, which is 729, right? But that's bits. So we could potentially pass in the digits into the bit conversion in the shader as well, which probably is where we want to go, because then we can pass in 81 digits and we can divide them by 4. So that's 21 pixels of data basically, if we use 8 bits per digit, which we don't need. We could probably bit pack it a bit more and do the unpacking in the shader. But that's neither here nor there, because it doesn't really give us performance advantages, because we have to do the packing already on the thing on the other side. I don't know how we do like binary operations, bit walking, and all this sort of thing. And also, we don't really want to deal with floats. But let's say, okay, so let's say we use 729 bytes, right? So we have 729, let's say, times 10,000. Let's say 10,000 matrices, right? Sorry, 10,000 puzzles. And we can pack 4 into each pixel. Right? So that'll be a 1.8 megabyte texture. And it'll be a square. How big? 1,350. So if we do it by blocks. Okay, so let's say we take textures that are 1024 by 1024. That's our number of pixels. We multiply by 4. We have 4 values per pixel. Right? And now we want to divide that by 729. Basically. At the most primitive. So that's 5,753 matrices. So we could maybe do 5,000. So what we could do is pass in 2,500 matrices, 2,500 puzzles, times 2 sets of 2,500 puzzles, and, or do we just do all of them against themselves instead of having 2 sets against each other? No, we need to have 2. We need to be able to do 2 sets against each other, right? Basically, that's what we want to do. Or does it make a difference? Yeah, because if we have multiple sets, we need to mix. We can't just do each set against itself. Then we have independent. We don't. No, I have no way of combining them, right? So if we divide that by 2, divided by 729, right? So if we do 2,500 by 2,500 per set, and currently I'm doing 1,000 by 1,000, but the hope is that it can do that in a frame. So yeah, then we just do a bunch of frames. We do 300 frames, and that's 2 seconds, and we're done. If we can do them in a frame. Okay, so I guess the first test will be to pass in uniforms, right? So basically just arrays. and to see if we can get them in and out. So let's do one called MA, right? We'll do that. Like that. We'll do 729. Item size 1. We'll just say new array 729. Dot map 1.0. Ciao guys, have a good walk. Oh, as well. Oh, it'll be a while then. Ciao. All right. And I got the wrong bracket here. Invalid value. Index out of range. Why? Enable vertex attrib array. Okay. Max length. But for big ints. Okay. Okay, no, that's not useful. Do array buffers. So do we have a size limit here? I mean, it definitely should be larger than 729. Ooh. Limit, no child, but the result is required to be 232 minus 1. The size of the vertex index array, which can be created using GLGet, but exceeds those limits, should only affect performance, not the final result. Draw elements into multiple calls, each drawing a subset of the data. For disconnected primitives is straightforward. For strips, just requires one or more. If I just make it smaller. Index out of range. Let's just see what this looks like. This just should be an area of 1.0s. Okay. Enable vertex attrib array index out of. Enable vertex attrib array. Attribute dot location. Attribute dot location. What the heck is that? All right, 230 something. Find that attribute. Enable vertex attrib array. Index out of range. What does that even do? Return value, a GL int number indicating the location of the variable name if found returns 1.0 otherwise. Program name. I mean, if found. I'm trying to add it. If so the first one works and the second one doesn't? Or is that because I haven't actually put it in here yet? Okay. So in MA float. I don't know if I even have access to integer things here. Int float item count 79. Doesn't like that. All right, let's replicate the thing that works. Right, and we'll make that vec2 MA. No, Really? If I take that out. If I move this to here. Is there a reason the names are like this? Maybe? Index out of range. What's the problem here? Oh. Oh. So it has to be used or something? Like if I do that? No. Doesn't seem to make a difference. Index out of range. This line here, vertex normal. Attribute. Attribute. I guess that's technically, so the inputs would be an attribute maybe? Sorry, a uniform? Like that? Unknown uniform type. Array buffer. I guess error buffers aren't valid. Uniforms? Three, 4, 9, 6, 2. Yes. Yes. Okay. You have to bind the buffer. WebGL doesn't directly set the state of most WebGL buffers. You have to bind the object and then refer to it based on where you bound it. Thanks, but I don't understand why does bind buffer require buffer as second argument. Buffer is unused in your example. Can't fill them directly. There's arguably no reason why the API should not have been a data buffer data hint. It's not. Note that WebGL has direct state access function. It's called name buffer data. It's rare for people to use them, just because the indirect way has been the normal since OpenGL shipped. In OpenGL 4.5 before that, an option extension. Okay. Buffer data node buffer. Create the buffer in the first line. Don't understand why I can't fill it with data. Can't just fill create buffer before binding to, or are there any reasons for this behavior? So, none of that actually helps me. Value. Why can't I pass that in? It should still just work down here. All right, let's do something here. So if I remove this. Okay. What? Oh. Okay. Okay. So if I could just copy this and call this A position 2. Okay. If I do this, A position 2. Okay. If I say A position 2 and use it in the program, it still doesn't like any of that. Okay. Let us add additional output error handling here. So 2, 3, 4. I have an error here. So let's do this. Try. Catch. Throw error. Dot error. In shader dot add attribute. Error. And then maybe these. Right, this music is too slow. This is also slow. Alright, that's a bit better. Hey, Olima, how are you doing? You've joined me for yet another Bang My Head Against the Wall stream, where I'm trying to do things that I don't know how to do. Alright, so we're getting an error here in around the line, the 220 line, which I thought I had now wrapped in error handling code here, but it seems to ignore that. Can we, I don't know, do this and then can I rerun this code? Including my error handling here? No? How to update preview. So, run it. All right. I do have a catch here, and it doesn't seem to catch anything. Why? I don't know why these try catches here don't work. Which line is this causing the problem? Enable vertex attrib error. Okay. Right? If I say console.log or and after. Oh, come on. Wow. Everything except what I wanted. All right. So we do this. Now we run that. And I'm guessing it'll print that, and not the exception. No, it does get me the after. Index value. So this is not an exception? What is this? No such thing as runtime errors, they're only undefined behaviors. Oh, god damn it. Enable vertex attrib array. Image out of range, yada yada yada. This is my vertex shader. What should I do? Suspect because you have an unused attribute vertex normal if you add a line into your code. Okay. Except I have that line in the code here. If I say VUV equals, let's say, right? That's A position 2. A position works. A position 2 doesn't work. Even though, in fact, we can just literally clone this. Now if I run this, it's working. God damn it. Oh my god, I hate that behavior. I hate that behavior so much. How are you supposed to write code when the only way for the code to run is when all the code is ready and perfect? You can't, like, add a line of code. Because where are the other lines of code? God damn it. All right. All right. I think I can leave this here. Still don't know exactly what this is doing, which is not great. But we've got the array going in without an error. So now let's see if we can make it bigger, right? So if I do item size this and make this 729 and then run it. Okay. And now we should be able to assign this to this. Like that. Save it and run it. And then we should be able to rename it as well. To MA. Wait, why does... Okay. All right. That seems to work. Now the question becomes, how do I get information out of it again? Here we have the out VUV, but it gets passed to the vertex shader. Can I modify attributes? So WebGL modify attribute. So varying p-text coordinates. Just use another variable. Uniform at 3U matrix. P GL position. Okay, wait, what? In my version, I would love to modify the attribute variable that is shared in fragment shader. By this modification, I should get image into Sudoku. Okay, well, I'm doing my shaders. Okay, so, but it's just in the shaders. Fragment shader value required equals can modify an attribute. Can modify an attribute. Just use another variable attribute. Uniform. Okay, WebGL get data out of shader. I think we need to do it via textures, right? Is this an AI thing? No. So prime time, output, frag color. So based on velocity, move each particle accordingly. Pulse shader, display on screen, display shader. Per particle. Yeah, but how do I get the data out? I don't want to process data in the shader and keep it in the shader. Look again, 1,000,000 points. Vertex gave it. Okay, well we can just write it as well, I guess. So we'd want to do that here, right? So we could just say this, right? The only issue is that I don't know how to access the different points. Except I do, because I've done it here. So if we're looking at game of life, so the fragment shader doesn't do anything special, right? So in the fragment shader, we are looking up the VUV coordinates, right? So what we would want to do is we would want to map the VUVs to the position in the puzzle. So probably what we want to do is here we're using get coordinates here. Coords float. So wait, coordinates gets us a 2D. And we're calculating these offsets, dividing it by the U size. Modulus. Because this basically does look at pixels above and below and all that. And we really kind of want to do a loop and do something similar, but in a different direction, right? So I'm wondering if we make our texture 729 pixels tall, right? And then go across. So if we have a 1024 by 1024 pixel texture, that we'd have our 290 down, and we'd basically read to, oh my gosh, I'm still trying to figure out how I'm gonna translate what the shader does into what I want to do, right? But basically, the fact that I can go on 3x3 means I can also go at 81 by 9, right? We just might have to write it out. I mean, even this could probably be done with a for loop. I'm personally just not familiar with it, so I have to figure that out. I'm just thinking, how do we... Because basically, we have, quote-unquote, for free, our UV coordinates, right? So if our UV coordinates are representative of the two puzzles we want to multiply, so we get two sets of puzzles that are mutually exclusive, and we deal with the puzzles that have with the sets that have overlaps with the self multiplication separately. Maybe we can. We could even just do them on the CPU then, or whatever. But the idea being, as we're going across the grid, across and down, every pixel should represent a pair of puzzles, and the position of that pixel, the UV coordinate, should be our reference into our textures for the puzzles. So then what we could do is, and I need to write notes. So UV scan U equals puzzle A, V equals puzzle B, right? And then for each puzzle, puzzles A equals texture A. So we have a texture for each puzzle, right? And then so we have for x 0 to 1024 equals 1023 equals 1024 puzzles, or y equals 0 to 7 to 8 equals 81 times 9 values. So that would be the rough version. Now, if we are bit packing, we can reduce this. We can reduce the 729 by 4, right? So we can say 7 to 9 divided by 4, so 183, or 183 pixels if using RGBA. And if we're doing that, then we could even have both sets of puzzles in one texture, or double the number of puzzles in each texture. Yeah, I think that's going to take a lot of setting up to get that to work. Not just setting up. I mean, part of what I'm doing is to remember how to do certain things. And then basically, let me have a look at WebGL for loop. I mean, it's definitely doable, right? So we can probably just do this. It's just going to be a little bit of a pain in the butt of like translating integer stuff to float stuff. But we could probably just say something like, or float I equals 0.0, I smaller than 729.0 I plus plus, right? And if I run that, I probably don't get an error. Nope, immediately get an error. Fragment shader is not compiled. Why? Syntax error. Oh, I forgot a closing brace here. Yeah, it's kind of strange. Try with an int at the total with a const if it's possible. That's the other thing. WebGL integer. I'd like to use integers if I can. Code question still shows up when I Google Web integer attributes. So I'll add an updated policy in WebGL. I mean, the other question is, like, I wonder if I can utilize the fact that it does fast floating point operations, but I don't think there's anything floating point that's going to help me in any way. Also, I think I'm still outputting this random array up here somewhere. Yeah, let's get rid of that. All right, so the idea then would be have a 1024 by 729 texture, for example. No, have a 1024 by 1024 texture, which is our output text. Okay, so now I'm starting to think a bit better. So we have the input textures with other matrices, but the output texture is just the result values. So the output texture is the same XY coordinate, and that's the number of matrices in each input of the two input textures. And this shader, the fragment shader, implements one instance of the multiplication, right? And this loop is gonna be a version of this little thing here. So we kind of should be able to do this. So let's just quickly see if we can translate this to shader, GLSL without it kind of becoming all screwy on this. So we'll do a float total 0.0. We'll do a float I and float J. We'll, do this. Keep the sanity alive. All floatify everything. Right. Float sum equals 0.0. Do this, do this, do that. And run while saving. And see if that lets us compile the shader at least. Okay, so that works. So now we do the same thing with K. Float K equals 0.0. K smaller than 81.0. Blah, blah, blah. Sum plus equals. And then we'll have our MA and MB. Okay. Now, that is going to be the texture lookups, right? So it's not going to be AB. It's going to be texture U texture. So if I do this, uniform sampler U texture, I'll say mat A and mat B, and then we'll do texture 2D. We'll do texture 2D off mat A, texture 2D, mat A, and then the get coordinates is returns what? A vec2. So our vec2 is going to be 1 is going to be the matrix we're looking at, which is going to be whatever, right? UV VUV dot X. And then the other one is going to be our this. I times 81K. And that's our first texture lookup. Let's call that, let's just look at the red channel, right? And then we'll do the same thing for mat B. And here we're looking at the Y. And then this one is gonna be K times 9 plus J. Right. And then these two get multiplied together. Like that. And sum is plus equals to that. I think that might work. Nope. Okay, that would have been a bit too easy. All right, fragment shader is not compiled. Why? Not matching overloaded function found. Texture 2D. U texture, which is a sampler 2D, which is our mat A, and then get coordinates returns a vec2. So we've got a vec2 in here, and then we take the R. No matching overloaded function. Wrong operand, not operand exists. It takes a left-hand operand of type medium float and a right-hand operand of const int. Oh? What? Oh, okay. My bad. Okay, that's not where I expect the issue. Well, that's always like that with GLSL. The errors always come from places which you really wouldn't expect. No matching overloaded function found. So it requires structure, vector, or interface block on left-hand side. Requires structure, vector, or interface block on left-hand side. Texture 2D. Texture 2D. No matching overloaded function found. No matching overloaded function found. Let's break it down then. Let's break it down. You got a vec2 IDXA, which is gonna be this, right? Okay. Vec2 IDXB, which is gonna be this. Right. Now we want to have a texture 2D outputs what? WebGL texture 2D. Texture 2D returns a vec4. Okay. So we have a vec4 val A equals texture 2D mat A IDXA, like that, right? So we put in a sampler 2D and then a vec2 coordinate. And where's the problem? Dimension mismatch. Constant cannot convert from constant medium float to medium 4 component vector of float. Constant medium p float. Okay, is it because I haven't actually passed textures in here? That's probably it. Now I need to figure that out, right? So let's see how quickly we can figure that out, because I need to go now. 5 minutes ago, the talk has started. Just a moment, just a moment. Let me figure this out. If I want to add a uniform, so it's a uniform U texture. Our textures are gonna be called mat A and mat B. So if I put a uniform mat A texture here, do we have a texture FB0? Sure, FB0. And this. And if I run that, is that gonna do away with those errors? Texture to D, no matching overloaded function found. We get rid of the second one. And then just run it again. Medium float component. We have this GL texture 2D texture and params. Blue color type texture 2D. I mean, that's all we're asking it to do here. And the textures are created where? Here. Get texture. Oh, wait. Maybe that's a necessary item. Okay. Texture 2D. Convert float to vec3. Try wrapping your dot product in vec3 like dot a RGB W. Dot product returns a float. Not doing a dot product. Just try just texture. Okay, so it's a syntax thing. Okay, maybe that'll help us. Not really what the error messages say in any way, shape, or form. Thanks, GLSL. That's why GSL is hard. It's not a hard language. It's just, my God, the reporting and messaging is horrific. All right, and all right. And maybe it doesn't even need me to pass it in the first place, or bind it, or whatever the words are. Okay, so in theory, that gets us the vowels now. And now we can do sum plus equals val A times val B. Right, and then total plus equals sum times sum. And we'll let the what's the word? The optimizer take care of the rest. Total sum times sum. Okay. Error. Assign. Can I go from medium 4 component vector to float to medium float? Sum is a float. Total is a float. Val A dot R. Val B dot R. And if we want to use RGB, times 4, we just subdivide these numbers by 4 and then pull out the relevant components. Maybe I can even use 1-bit textures or something. Maybe that'll fix it as well. All right, it runs. I don't know what it does. In theory now, our out color would just be the total scale to some sort of well, basically the out color should be total minus 81. Yeah, so I guess that's it, right? Out color should be total minus 81 to, but divide 81.0 divided by 729.0 minus 81.0. And that should give us a value from 0 to 1, right? Now, that's actually, yeah, that's just the value. So we could just put that into something like vec for, you know, this could be our RGB value, our red value. And then we'll set the rest to 0, alpha to 1, so we can see something. And now we just need to pass in the matrix data as textures. In theory. Huh. So I guess the next step would be to create 2 canvases that I can draw into for now. So I can visualize it. It would be kind of nice to see, actually. And then this needs to be exactly 1024 by 1024. We have to, you know, do that a little bit. And then we can just read the colors of the output of the canvas here to get our results. And probably initially we want to do this with a much smaller texture, like 10 by 729 or whatever. 10 by 10 on the original output, and see how that works. I mean, how slow could it be? It's a GPU. It's supposed to be fast, right? And it should, in theory, kind of do a lot of these in parallel, right? Just like what I was doing with my CPU cores. And then the question is, can we optimize it, right? Because we don't need floating points. We're literally just checking if numbers are ones or zeros. And in fact, the multiplications could be replaced with just checking if they're both ones or not or whatnot, right? Like a bit pattern lookup kind of thing. Don't even know if that would be faster on the CPU side. Get rid of the multiplication and just make it a bit pattern lookup. Like, make the whole thing Boolean, right? All right. Anyway, that's it. I gotta join the talk. I'm already 10 minutes late. Thanks so much for hanging out, and sorry for the short and early stream today. But there's a lot of stuff happening, a lot of things that make my brain hurt. So hopefully soon there'll be results that I can show off. I'm looking forward to that. Thanks for hanging out. Take care, guys. Bye-bye. See you guys in the next one. Have a good day.